In today's class, we are going to study about the conservation of linear momentum. And conservation of linear momentum, before going to the topic, you should know what is the momentum. Already we have discussed what is the momentum. Momentum is the quantity of motion contained in the body. And the formula for the momentum we have already seen, that is P is equals to mv. P is equals to mv. Now, students, in today's session, we are going to study the conservation of linear momentum. That is, I can say the law of conservation of linear momentum. So let us give the heading law of conservation of linear momentum. So what is this law of conservation of linear momentum? Students, we know this already, that the force is the rate of change of momentum. The rate of change of momentum is force. Let us go with the definition of force itself. F is equals to what this we know already, dp by dt. Now, according to the law of conservation of linear momentum, what it says, whenever the external force acting on an isolated system, I can say whenever the net external force acting on a system is zero. जब भी नेट फोर्स जब एक सिस्टम पर जीरो होता है बेटा, नेट फोर्स जीरो होना है, इट डजंट मीन दैट नो फोर्स एक्ट्स ऑन दैट. द फोर्स मे एक्ट, बट पूरे फोर्सेस को अगर हम ऐड करते हैं, इफ यू आर एडिंग ऑल द फोर्सेस, देन द आंसर इज द नेट फोर्स इज जीरो. I hope it is clear. So if the net force acting on the system is zero, then we say the momentum is conserved. The momentum is constant. How it is? Let us see mathematically. So, but this we know as per the question, if F is equal to zero, if F is equal to zero. So if F is equals to zero, the definition of force is dp by dt we know. So what I do, if F is equals to zero, then 100% dp by dt must be zero. dp by dt is equals to 0. Now, as for mathematics derivation, that is derivative part, I can say, we have having differentiation concept, the concept of differentiation. And the differentiation of any constant is 0, as you know. So, this is what dp by dt is equals to 0. That means we are differentiating p, we are differentiating momentum with respect to time, then it is 0. So, that means if I differentiate any constant, I am getting 0. So, therefore, p is constant. That is, momentum is constant, momentum is conserved. This is a very simple law what we have in physics. So once again, let me tell you, whenever the net force acting on the system is zero, then the momentum of that system is always conserved. It always remains constant. It is not going to increase, it is not going to decrease, it always remains constant. I hope it is clear. Now, this is the law of conservation of linear momentum. Now, students, let us go for the applications where we can apply this law of conservation of linear momentum. The first one, what I am considering is the collision. Try to understand collision, how to apply this law of conservation of linear momentum before collision and after collision. So let us see, suppose for this, I'll give you an example. A body is there of mass m1. It is moving with velocity u1. Another body is there of mass m2 moving with velocity u2. This is before collision. This is the situation, this is the scenario before collision. So this I will write this as before collision. And one condition we need to assume, students, here, u1 is greater than u2. What is the reason of assuming this? The reason here is, if u1 is equal to u2, then this separation will remain constant. They are not going to have the collision. If suppose this u1 is less than u2, this value is less than this, sorry, this value is less than this, then what happens, this will move forward and this will be just, it is just falling, that there will be no collision at all. In order to have the collision, this velocity u1 must be greater than u2. ये ज्यादा तेजी से चलना है, ये ज्यादा तेजी से चलना है इससे, then only it is going to collide. Now what happens, let us see. Here collision has taken place, यहाँ पे collision हुआ बेटा. अब collision के बाद just imagine a body of mass m1 is moving with the velocity v1. This is v1, and the body of mass m2 is moving with the velocity v2. Both are moving in the same direction. Now, as per the law of conservation of linear momentum, how to apply this? See, the one condition what he says, the net force acting on the system is zero, then the momentum is conserved. That means momentum is constant. What is the formula, or what is the momentum of this body? It is moving with a velocity u1 and it is having the mass m1, and momentum is mathematically it is equal to the product of mass and velocity. So therefore beta यहाँ पे अब आप देखिए what we are getting, this is what mass and velocity. So this is m1 u1. What is the momentum of this? इसका momentum कितना होगा बेटा? यहाँ पे देखिए आप m2 u2. This is m1 u1, this is m2 u2. This is the momentum of individual bodies before collision. Are you getting my point? This is the collision, these are the momentums of the bodies before collision. Then what I do, I'll calculate the total momentum by summing this. This is the total momentum. Now, what is the momentum of this body after collision? It is moving with v1 and the second body is moving with v2. So therefore the total momentum now it becomes m1 v1 plus m2 v2. That what you have here is the momentum of the first body plus momentum of the second body. I hope you have understood. Now, as per the law of conservation of linear momentum, this momentum before collision, that is the total momentum before collision, must be equal to the total momentum after collision. I hope it is clear. This is the first condition, I can say the first application where we can apply the law of conservation of linear momentum. I hope it is clear. Now students, let us go for this is like recoiling of gun. Second example I am giving. Second, recoiling of gun. What do you mean by this recoiling of gun? See, when a bullet is fired from the gun, this is the bullet. When it comes out, no, what happens? This gun will have the backward kick like this. It has the backward kick. So what happens? The bullet moves forward and the gun takes the backward kick, and that backward kick we are calling it as the recoiling of the gun. I hope it is clear. Recoiling of the gun, that is the moving of the gun in the backward direction once it is fired, that is called as the recoiling. I hope it is clear. Now, what the situation we can apply, and how to apply the law of conservation of linear momentum under this situation, let us see. देखिए बेटा यहाँ पे what we are doing, just imagine the gun, this is the gun and this is the bullet. Now what I do, as per the law of conservation of linear momentum, I have to consider the total momentum before firing must be equal to total momentum after firing, what we have studied. So here I will write the same thing, momentum before firing must be equal to momentum after firing. Before firing and after firing, the total momentum must be constant. So before firing, this gun along with the bullet, are they are moving? No, they are not at all moving. That means what is the velocity, initial velocity of the gun? It is zero. What is the initial velocity of the bullet? It is zero. That means u1 is zero as well as u2 is zero. But students, suppose after firing it is moving with the velocity v1. After firing, ये फायरिंग के बाद कितनी वेलोसिटी है इसका? That is v1. Now this is recoiling, I can say, with the velocity v2, that is after firing. Suppose this bullet is having the mass m1 and the gun is having the mass m2. So in order to apply the law of conservation of linear momentum, what is the initial momentum of the gun? Initial momentum of the gun is zero. What is the reason why I'm writing it as zero? Because the velocity is zero. It was not moving. What is the initial momentum of the bullet? It is also zero because it's not get fired yet. So therefore, what I say, the momentum of the bullet as well as the momentum of the gun, both are zero. But after firing, What is the momentum of the bullet here? M1 V1, M1 V1 plus the momentum of the gun. It is M2 V2, M2 V2. Now, students, if I take this term, this side, that is M1 V1 is equals to minus, I have to write here, minus M2 V2. Why I am getting this minus sign? The question is why I am getting this negative sign. You can see here, negative sign I am getting. The reason of getting negative sign is if the bullet moves forward, then the gun have the backward kick. That backward kick is indicated by that minus sign that indicates just the opposite direction of the direction of motion of the bullet. I hope it is clear.